Welcome back. This is Mr. Eicher. Welcome to Math 3. This is a video talking about our Chapter 2 practice test number 2, the solutions, for questions number 7 through 13. Let's get started. Alright, let's see. What do we have here? Solve using factoring, following the directions. So, when factoring, it's really helpful if the equation is set equal to 0. This first guy is not set equal to 0. So we're going to move that negative 4x, adding 4x to both sides, so we get 4x squared plus 4x, so we'll put it in the middle because I'm going to want it there eventually anyway, equals 15, or sorry, minus 15 equals 0. Now we need factors of 15 multiplied to factors of 4 that add to give me a negative 4. That's kind of a lot to take in. So we can organize it with this little x here. So we'll take the negative 15 times 4, that would be negative 60. And this 4 just goes in the bottom, plop right there. And we want what multiplies to 16 that adds to 4. 15 times 4, that doesn't seem like it would work. 10 times 6 would give me 60, and there is a way to get to 4 if I make the correct one negative. So let's see, I want a positive 4, so I'm going to make this one negative. So we can rewrite these three terms in green here, these three green terms. We can rewrite it. The first term stays put, 4x squared. We're going to write negative 6x plus 10x. That's how we're using this 10 and this negative 6. And then minus 15. Equals 0. And then we factor by grouping. We're going to group these first two terms. We're going to group these last two terms, take the greatest common factor out. Wow, look at those braces. Man, those are nice. Maybe the best ever. So between 4 and 6, there's a 2. And there's an x as well, isn't there? They both have a factor of 2 and a factor of x. Dividing that out, we get 2x left over minus 3. And on the other side, we can factor 5 out, so plus 5. And we get a 2x minus 3 equals 0 still. And then notice that we have this guy right here, and that's identical to this guy. So we can factor those out, and that comes out in front. We get a 2x minus 3. Factor that out. And then we're left with this stuff on the inside, the 2x and then the plus 5. 2x plus 5 equals 0. And we're supposed to solve for x. So the zero product property, if these two quantities multiply to give you 0, either the first one equals 0 or the next one equals 0. And that's only true when multiplying two numbers and you get 0, the zero product property. So we get x is 3/2, or x is subtract 5 divided by 2. So there are our answers. Put a little circle around them. There we go. And let's see if I can do a little division here. Hope that doesn't aggravate you that it's not a straight line. Okay, so again, solve by factoring. We want it set equal to 0, and sadly, this guy needs to move, but he's very willing and able to move. So we have 9x squared minus 18x. Put it in the middle. That's where we want it eventually anyway. Minus 16. Now it's equal to 0. Isn't that fantastic? So let's see. These numbers, 9, 18, 16. They don't have any common factor. Sure, it'd be nice if I could have divided something else, but let's see. Do our little organization here. 9 times 16. That's a negative, but let's see. Is that 144? 54. 54, carry the 5, put the 4 down there. Yeah, 144. And it's a negative 144. And then negative 18. So let's see, factors of negative 144 that add to 18. 12 times 12, that's not going to help. Let's see. How about 24 times 6. Just took a factor of 2 from this 12 and multiplied it to 12 to get 24. So 24 and 6. So negative 24 and positive 6. Okay, so we can rewrite that original as 9x squared minus 24x plus 6x minus 16 equals 0. And then take the greatest common factor. Those are pretty nice braces too. This is like National Brace Day. So we get, let's see, we could take a 3 out of both, a 3x. And that's a 3x left over when you divide it out, and that would be a 8. And then we could take a 2, and that's a 3x, and that's a minus 8. They should be identical if you're using this method, right? Notice we get a 3x minus 8, and we get a 3x minus 8. And that's good news. So we have 3x minus 8 that we factored out, and we have 3x plus 2 equals 0. And then solving from there, set both equal to 0. That would be 3x minus 8 equals 0. 3x plus 2 equals 0. And I've run out of space, but I'll write the answer up here. We get x equals 8/3, comma, and the other one is negative 2/3. Right there is my answer. Wow. We're able to get through 2 factoring ones. Let's look at the next one now. We have solved the equation using completing the square. This should be fun. So completing the square, we want to rewrite the first 2 terms, the x squared and the x term. We'll put plus blank. And the 23 is kind of in the way, so I'm going to subtract it to both sides, so we get a negative 23 on the right. And to figure out what goes here, you're going to take the negative 10 over 2 and square it. That formula is b over 2 squared. Or you can kind of logically figure it out, but that would be a 25. But be careful that you add 25 to both sides. Alright, so now we can factor this. This is a perfect square trinomial. It's a perfect square because when you factor it, you get something squared. Perfect square trinomial. La-da, da-da, la-da, equals 2. X minus 5 squared equals 2. And then solving there, we can use the square root property. We'll square root both sides. Being very careful. Maybe I won't write it and see if you recognize. X minus 5 equals the square root of 2. Did I forget something? Of course I did. The plus or minus, that's what everyone forgets. And then x equals 5 plus or minus square root 2. And that would be my answer. Those are kind of fun. I like completing the square. The next question, quadratic formula. Not sure if I have enough space, but we'll see. Let's see. We have the a value is here, a, and then b is negative 6, and c is 3. So let's see. X equals negative b, so 6, plus or minus the square root of b squared, 36, minus 4 times a times c, 4 times 6. 6 came from 2 times 3, a times c, over 2 times a, 2 times 2. So we get 6 plus or minus square root of 36 minus 24, I think that's a 12, over 4. The square root of 12 you can break down into a 4 and a 3, and then this 4 you can take a square root of 4. So that would be 6 plus or minus 2 root 3 over 4, and the 6 here, the 2 here, and the 4 here are all divisible by 2. So divide by 2 and you get 3 plus or minus root 3 over 2. And I believe that's our answer. Let's move on. This question is kind of a pretty fast question. This is basically, do you understand how to complete the square? And we just did that on the previous one. So again, the formula is b over 2 squared. So in this case, b is negative 22. So you have negative 22 over 2 squared. That would be negative 11 squared. So our answer is 121, 11 times 11. The next one is a little more interesting, I guess. You'd have negative 4 over 7 over 2 squared. That would be negative 4 over 14. The 7 and the 2 multiply to each other. And then we can simplify that a little bit. We get 2 over 7, negative 2 over 7 squared. So it looks like 4 over 49 is what we would get. Alright, I guess we're good with that. That took all of not very much time. Let's look at the next one. Alright, we got find a quadratic equation with integer coefficients. So we want the answer to look like this. Y equals ax squared plus bx plus c. If the roots are those, then those are our solutions. So we had something like x minus something equal to 0, that when we solve this, we eventually got x equals 3/4. Or we had x minus something, we'll just say like b or something, equals 0. And when we solved it, eventually we got x equals negative 6. So that's kind of what we're being asked for here. So one way that you could think of it is we had x equals 3/4. If we rearrange this, if we multiply both sides by 4, we get a 4x equals 3. And subtract 3 from both sides, and we get that. This then was one of those factors that we solved to get 3/4. We could do the same thing on this side. X equals negative 6. Add 6 to both sides. And then this is the other one that we're looking for. So then we would have 4x minus 3 times x plus 6 equals 0. And we can multiply that out to put in the correct form that we're looking for, this form right here. So let's see, distributing, we get 4x squared plus 24x. And then distributing these guys, we get negative 3x minus 18. We still have it equals 0, but my screen ran out of space. So it looks like our answer would be 4x squared plus 21x minus 18 equals 0. That is the equation that has integers for coefficients. All of these should be integers. Integer, 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 integer. And it's an equation, it's a quadratic, it has the squared term. So we're all done with that. Let's look at the next one. Projectile motion. Good old physics. So we have an equation here for the height of an object that is fired at some velocity 64 and an initial height of 24. Find the maximum height and the time to reach the maximum height. So you'll notice this leading coefficient's negative and it's quadratic. So it probably looks something like this, where this is time and this is the height of the object. Notice I started right about here, which is our starting height of 24. So you'd like to know the maximum height, which is this guy, and the time it took to get to the maximum height. So we're going to use our handy-dandy formula. X equals negative b over 2a. And that will give us the time t. So we could actually call this t equals instead of x equals. T equals that. So we would have t equals negative b, negative 64, over 2a, 2 times a. And the numbers work out wonderfully. You're welcome. That would be after 2 seconds the object reaches its maximum height. What is that height? well then we would evaluate h of 2 to find that height. Negative 16, 2 squared, plus 64 times 2, plus 24 to find the maximum height. So that would be negative 64, I believe, plus 128, plus 24, 64 plus 24, 88, and the units are feet. So the object reaches its maximum height after 2 seconds, and what is that height? That height is 88 feet. Let's look at the next one. Graph the inequality using vertex form. So that's good. We get to complete the square. So we have y, we'll just say equal to for now. We'll ignore the inequality, come back to that later. Negative 3. We're going to factor out that negative 3, so we have x squared minus 4x, because we took a negative 3 out, divided negative 3, plus blank, equals, minus 7. Better. And we need the value here, so 4 over 2 squared is 4, so we won't actually add 4 to both sides, but we will add negative 12 to both sides. We add negative 12 because the 4 stuck in the parentheses, so it's really not 4 that we're adding. It's really, on this right side of the equation, it's actually a negative 12 that was added. So we'd have y minus 12 equals negative 3. Something squared minus 7. And the something would be x minus 2. Is what you get when you factor this piece right here. Cleaning it up a little bit, we get y equals negative 3, x minus 2 squared. Adding 12 to both sides, that would be a plus 5. So graphing, we'd have 2 comma 5. That's right here, 2 comma 5. It is going downhill. I remember our little trick that we did when we are squaring something. 1, 2, 3. Normally it's 1, 4, 9. But we are multiplying by that negative 3. That a value. So that means we're going to go right 1 and down 3. And we're going to go right 2, down 12, if it'll fit. So right 1 down 3 is right here. And then from the vertex right 2 down 12, I believe is right there, and it barely fit. But it fit nonetheless. And then with symmetry we can graph these other points. And the y-intercept is 7, notice that. That makes sense given this value here. So before I connect the dots, should caution you that, remember, this was an inequality over here, and we want a dashed line. Let's see if I could do dashed on this. There you go, dashed. And to test a point, we'll test 0, 0. Is 0 less than 0 plus 0 minus 7? Is 0 less than negative 7? That is false, so we should not shade where 0, 0 is. We should shade on the other part of the region, which is on the inside. There you go. I think that's complete. That's graphing in vertex form. Good, completing the square practice. Let's look at the next part, part B. Again, we're asked to graph in vertex form, or to put it into vertex form. So we would have y plus blank equals. We're going to factor a 1/2 out, and be careful here. You'll have x squared, and that'll be a plus 4x plus blank, and the minus 3 gets pushed to the side. It became a 4 because you can always check your work. 1/2 times x squared is 1/2 x squared, that's that. And then 1/2 times 4, it better be 2x, and it is 2x. Okay, so what value should we add? We should add 4 here, but that would really be adding only 2 to the left side of the equation. Okay, so we have y plus 2 equals 1/2. That would be x plus 2 squared. You factor that, minus 3. So y equals 1/2 x plus 2 squared. And subtract 2 from both sides, we get a minus 5. So these two numbers will give you the vertex. The vertex is -2, comma -5. And then the 1/2, if you use our normal table here, 1, 2, 1, 4, these are going to multiply by 1/2, 1/2, 1/2. So we're going to go right 1, and we're going to go up 1/2. Then we're going to go right 2 from the vertex, and then up 2. So right 1 up 1/2 is kind of difficult there, but then right 2 up 2, that looks like right there. And then with symmetry, we have that point and that point, I think. Do we need to worry about shading? Thankfully, it's an equal to sign. You see that right here. So it's just a solid line with no shading. So there you go, something like that. And it does have 5 points that we graphed. Those 5 points. All right, that was a graph. Good completing the square. This kind of guy completing the square process there. Let's look at the next one. All right, so we have some operations with imaginary numbers. We have to distribute, so we'd have 5 minus 14i minus 6 plus 12i. Careful of that negative. Combining like terms, these two are like terms, and then these two are like terms. So we would have 5 minus 6 is -1, and -14 and positive 12 is negative, -2i. And that looks like our answer. Pretty fast on that one. And that ends this video part 2. Join us next week, or tomorrow, or in 1 millisecond, to part 3, the last part, going over answers to practice test number 2. Thanks for watching.